All right, so we are going to talk about adding and subtracting rational expressions. A rational expression basically is a fancy word for saying that you have fractions, which I know you guys hate, okay? But here's your rules. When you add rational expressions with the same denominator, you keep the denominator and you basically add or subtract the tops. When you have different denominators, you have to get a common denominator, which is always going to be, it might not be the smallest, but the fastest way is to multiply the first two by the bottom of the second. So that's where they got the UZ and then they got the VZ on this side. And then you take these two and you multiply by V, that's where they got the VW and the VZ. So you get a common denominator and then you add your new numerators. When you multiply straight across the bottom, straight across the top. When you divide, you have to keep, change, flip. So you keep the first one, we change divide to times, and we flip the second one, and then you're right back to straight across the top, straight across the bottom. Okay? So, 5 ninths plus 10 ninths. Well, when the denominators match, you keep the denominator, and you do the math on top, which would be 15 over 9. Don't forget to reduce if you can. Each of these can be reduced by 3, which would give me 5/3. Okay? Here, the denominators don't match. If I take 3 times 24 and 5 times 24, I get 3 times 24 is 72. 5 times 24 is 120. So if I can rewrite this fraction as 72 over 120. If I take the 5 and the 24 and I multiply 5 times 5 and 24 times 5, dyslexic question, 24 times 5, you take each of these and multiply it by that one. 5 times 5 is 25, 24 times 5 is 120, so this new fraction becomes 25 over 120, and now my denominators match. So I keep the 120 and I do 72 minus 25 on top, and I get 47 over 120. And you could try and reduce, but I'm pretty sure 47 is prime. Alright, so if you got 3, you just go 2 at a time. 2 sevenths minus 3 eighths. I'm going to take 2 and 7 and multiply by 8. 2 times 8 is 16, 7 times 8 is 56. So this fraction becomes 16 over 56. Then I'm going to take the 3 and the 8 and multiply it by 7. So 3 times 7 is 21. 8 times 7 is 56. So this fraction becomes 21 over 56. So now if I keep that denominator and do 16 minus 21 on top, you get negative 5 over 56, and I can't reduce it. So now we're going to do the plus 5 over 13. So to get a common denominator here, I'm going to take negative 5 and 56 and multiply by 13. Negative 5 times 13 is negative 65. 56 times 13 is 728. So this new fraction becomes negative 65 over 728. To rewrite my second fraction, I'm going to take the top and the bottom and multiply by the bottom of that one. So I have 5 times 56 and I have 13 times 56. 5 times 56 is 280. 13 times 56 is 728. So this new fraction becomes 280 over 728. So that now becomes, I keep the denominator, 728, and I do the math on top, which says negative 65 plus 280. Negative 65 plus 280 is 215 over 728. And me, I type it in the calculator and do math, enter, enter, and it gives me back 215 over 728, which means I can't reduce it. Okay? Now, yes, guys, I realize that you can just type this in the calculator and hit enter and get an answer that way, and obviously check. But you're supposed to be, this is going to turn into polynomials in a second, and the calculator is going to do you no good anyway. Alright? So, multiplying. Multiplying is straight across the top. 20 times 9 is 180. 21 times 22 is 462. And again, I'm not going to reduce by hand. I type in 180 divided by 462, math, enter, enter it, and that reduces down to 30 over 77. Straight across the top is 8, straight across the bottom is 45. You can try, but if you type 8 divided by 45, math, enter, enter, it gives you 8 over 45 back, which means it can't be reduced. Alright, so you try this one, hit pause, come back when you're ready. Alright, I'm going to do the first two first. So I have 1 over 11 plus 1 over 44. Now, guys, you can always do what I taught you. Okay, you can take these two and multiply by 44. 1 times 44 is 44. 11 times 44 is huge. 484. So this fraction I can write as 44 over 484. Okay, this one, if I take these two and multiply by that, 1 times 11 is 11. 44 times 11 is 484. So that becomes 11 over 484. If I keep the denominator and do the math on top, I get 55 over 484, which is not the answer because this can be reduced. 55 divided by 484, math, enter, enter, reduces down to 5 over 44. Why do we get 3? Oh, that's just these two, silly goose. So now I need to subtract 122. So I have 5 over 44 minus 1 over 22. Again, you're getting big numbers because, see, back here, my lowest common denominator would have been 44. I could have just multiplied this first fraction by 4 and got a common denominator, which would have saved me having to reduce at this point. But what I'm saying is, if you're not comfortable with fractions and you don't catch that, it's not a big deal because we have math, enter, enter, and that'll take care of it for us. Alright, so to finish up over here on this side, I'm going to multiply these two by 22. So 5 times 22 is 110. 44 times 22 is 968. So I can rewrite this fraction as 110 over 968. And then my 1 over 22, I'm going to multiply both of them by 44. 1 times 44 is 44. 22 times 44 is 968. So that fraction becomes 44 over 968. So I would keep my denominator and do 110 minus 44 on top, which gives me 66 over 968, which isn't there, because if I do 66 divided by 968 and math, enter it, it reduces down to 3 over 44. Okay? Alright, so you do this one, hit pause, come back when you're ready, and hopefully you got 1/3. When the denominators are the same, you keep the denominator and do the top, which gives me 3/9, which reduces down to 1/3. Okay, multiply, hit pause, come back when you're ready, and hope you got 2 over 15. 3 times 8 is 24. 20 times 9 is 180. Type in 24 divided by 180. Math, enter, enter. And it reduces down to 2/15. Okay? Divide. Go. That was weird. I didn't do any division. And hopefully you got 3. If you did not, remember your keep, change, flip. So I'm going to keep the 10 11s. I'm going to change the times, and I'm going to flip the second one. And now it's back to multiplying. So straight across the top is 50. Straight across the bottom is 22. That answer isn't there because if you math enter this, it reduces down to 25/11. Okay? So how do you add and subtract rational expressions? Well, you get a common denominator, then you keep denominator, and add or subtract the numerators. How do you multiply rational expressions? Top times top over bottom times bottom and reduce. How do you divide rational expressions? You keep, change, flip, then top times top over bottom times bottom and reduce. Okay? Alright, it says finding the domain of an algebraic expression. Well, we've been doing this since the beginning of the year. Nothing is going to change. You get restrictions on domain when you have variables in the denominator or variables under radicals. Same thing. To get your no-nos for denominators, set your denominator cannot equal 0 and solve for x. That's what x can't be. Variables under radicals, set the radicand greater than or equal to 0. This is what x must be. So, it says find the domain of the algebraic expression. There's no denominators and no radicals with letters under them. So there's no drama, which means my domain goes from negative infinity, and I'll use the bracket there, negative infinity to infinity. And if all else fails, look at the picture. It's a parabola. That goes forever right and forever left. The domain is all numbers. Okay, a radical with a letter under it, we've got drama. So we say, Mr. Radical, you must always stay positive. So if I solve this, to kill the square root, I'm going to square. That would give me x minus 4 greater than or equal to 0. Add 4, add 4. X has to be greater than or equal to 4. So if I drew that on a number line, from 4, it can include it and be anything to the right. So my domain starts at 4 and goes to infinity. And if you look at the graph, you can see there's the 4. All of my graph is to the right of 4 on the x-axis. Okay, so it goes from 4 to infinity. Alright, let's look at this one. We have to tell Mr. Denominator that you may never equal 0. To solve this, there's two terms, so I'm going to factor. I can do a GCF by x. If I factor out an x, that would leave x plus 3 cannot be 0. So x cannot be 0, and x plus 3 cannot be 0. Solve them. That one's done. Minus 3, x cannot be negative 3. So if I drew that on a number line, 0 is going to have a hole, and negative 3 is going to have a hole, but everything else is good. So again, to describe that, my domain starts at negative infinity, stops at negative 3, starts again at negative 3, stops at 0, starts again at 0, and goes to infinity. And if we look at the graph, okay, there's my negative infinity to negative 3. There's my asymptote, right? So I have all this graph over here. There's that boomerang. Then I have between negative 3 and 0, see the other asymptote? I've got this, I don't know what that is, part of an S-curve it looks like. And then from 0 to infinity, I have this other boomerang, okay? So you can always check your domain looking at your graph. Now, your author's kind of funny here. He's giving you an extra restriction that has nothing to do with the denominator or there being a radical with a letter under it. they're giving me an extra one. They're already telling me that at 2, there's going to be a hole for whatever reason. Okay, in addition to restrictions, I cannot have a denominator equal to 0. So add 1, x cannot equal 1. So there's going to be another hole at 1, which means everything else is good. Okay, so I'm trying to get a good color here. So all of this is good, in between is good, and all of this is good. Which means my domain starts at negative infinity, stops at 1, starts again at 1, goes to 2, starts again at 2, and goes to infinity. And if I looked at the graph, okay, I have got negative, or at positive 1, I've got a gap, and then I'm told at 2, I have to exclude that also. It doesn't show up in the graph, but I have to show it because the author said it can't be. Alright. Here, it looks like we don't have any drama. Oh, but we do. Remember, this is x squared plus 1 over x. Okay, so your drama is going to come from right here. Mr. Denominator can never equal 0, so x can't be 0. The only thing excluded is going to be 0. X can be everything else. So my domain starts at negative infinity, stops at 0, starts again at 0, goes to infinity. And if I look at the picture, there's my asymptote right there at 0. Oops. How do I get out of that? Okay, there's my 0. And you can see there's graph on this side that's going to go from negative infinity to 0. And then it starts again at 0 and it'll go forever. Alright, here we've got two restrictions. There's a radical and the radical's in the denominator. So you do each one separately, and all that's going to be different is whether the circle is filled in or not. First of all, you have to say, Mr. Radical, you must always stay positive. So if I square both sides, I get x plus 4 must be greater than or equal to 0, minus 4, x must stay greater than or equal to negative 4. So if I graph that, negative 4, closed circle, and I can have anything bigger. Now, if I do my other one, and I say, Mr. Denominator, you can't equal 0. You see, the only difference in these two statements is the or equal to. So I'm going to get the exact same thing when I solve it. Square both sides. X plus 4 can never equal 0. Minus 4, so x can never equal negative 4. Which all that means is it changes that closed circle to an open circle. Which means my domain starts at negative 4, but it doesn't include it. And it goes all the way to infinity. And if I look at my picture, there's my negative 4. But it doesn't include it. That's an open circle. And it goes forever to, kind of looks like the Nike swoosh. Goes forever to infinity. Okay, again, your author's being a jerk. It doesn't look like there's anything wrong with this, but the negative exponent means this is really y plus 2 over y minus 7. So you have to say, Mr. Denominator, you can never equal 0, which means y can never equal 7, which means on a number line, 7's going to have a hole, but everything else can be included. So my domain would start at negative infinity, stop at 7, start again at 7, and go to infinity. And if you look at the graph, and I counted by tens, I do believe, so 7 would be about right here. Okay, oops. 7 would be about right there, because I'm counting by tens. I wanted you to see that, I kind of wanted you to see that horizontal asymptote, but we'll talk about that later. Okay? Alright, so on this one now, be careful. I mean, I can say, Mr. Denominator, you may never equal 0. So x squared may never equal 25, square root, x may never equal plus or minus 5. Okay? So you're going to have 2, but remember, one of them is just going to be a whole. I mean, it's still, on a number line, you can't have negative 5 included, and 5 can't be included. but everything else can be included. So your domain would start at negative infinity, go to negative 5, start again at negative 5, stop at 5, start again at 5, and go to infinity. Now, remember though, oh no, never mind, it wouldn't cancel out. Alright, so, oops, darn it. If you look at the graph, darn it. If you look at the graph, there's your negative 5, there's your positive 5. Okay, and you have graph everywhere but there. Alright, so you try this one. Hit pause. Come back when you're ready. This one's a little funny. Okay, there's actually 2 answers that I will accept. You have to say, Mr. Radical, you can never, or I'm sorry, you have to stay positive. So when I solve this, I'm going to square both sides, and I get x squared minus 16 greater than or equal to 0. Add 16, add 16, x squared has to stay greater than or equal to 16. Square root, x has to stay greater than or equal to plus or minus 4. Now, what happens is, if you look at that on a graph, it would say that x has to be greater than positive 4, and x has to be greater than negative 4. However, because of the negative, okay, the plus or minus, on the negative one, that inequality is actually going to flip. So you actually are going to end up with a domain that looks like this, okay? Now I need to caution you, I think your answers are different because I caught the mistake in the author. I used the author's answers. And your bottom answer, I do believe, has your inequalities pointing the other way. Okay? That's a typo. Okay? And if you look, so what I'm saying is, this is my domain, which says x has to be less than negative 4, or x has to be greater than or equal to 4. Okay? This one, again, this isn't wrong. The only thing I can figure is that the author, I don't know what the author did. This isn't wrong, but people don't write the answers this way. Usually, if they're writing an in-between statement, your arrows have to be pointing the other way. But if you look at it, this says that x has to be smaller, because this says x is less than negative 4, which is all of these. And this side says x has to be greater than 4, which is all of these. Okay, so you can write your answer either way. Okay? And if you look at the graph, you can see there's my negative 4, there's my positive 4, and you have graph all the way to negative infinity and graph all the way to positive infinity, but nothing in the middle. Alright, so how do you determine the domain of a rational expression? Denominators can never equal 0, and radicals have to be greater than or equal to 0. Radicals with letters underneath them. Okay? Alright, so we are at homework, which means we are done. Happy homeworking, and I will see you next time.